Students, in this class we are going to do few problems on work done. Let's take one example. See, this is the block of mass m is kept over a surface. Well, let's say the surface has a coefficient of friction of mu. Okay, and we have to find out different types of work done we will do. Okay, I mean the work done by the applied force, the work done by the gravitational force, and the work done by the force of friction. Such kind of forces we will do. Let's start with the one. Here, if you take the body and a force is acting on, here is the weight of the body which is working vertically downwards. Is the weight. Okay, students, and immediately the surface will ask, what is that of a opposing force, and we call it as the normal reaction. Okay, students, and is the force which is acting on, and we are dividing the force into components as the theta, and you can write it as F cos theta, and we have another component which is equal to F sin theta. Okay, students, if the body starts moving in this way, obviously the frictional force will act in this direction. Let's say it is the frictional force F, and you have to represent here also, nothing will happen. Let's start with the first problem, students. The first problem goes like this. What is the work done by the gravitational force? Is the first question, students. Here, see this is the body, the same body I am showing you, and it is a component of the force which is acting in this way. Then we have to do is a normal reaction. Okay, what is the work done by the gravitational force? See this. Since force and displacement are in perpendicular directions, that is theta is equal to 90 degree. If you apply the relation, work done is equal to Fs cos theta, here theta is 90, then work done is equal to Fs into 0. Okay, students, is the work done by the gravitational force. Is the first case. Let's do one more, work done by the normal reaction. Okay, the second one, work done by normal reaction. Obviously, we yield the same results. It is the theta, and again work done is equal to Fs cos 90. Okay, since it is 0, then work done is equal to Fs into 0. Work done is equal to 0. That means the work done by the gravitational force and as well as the normal reaction is equal to 0. Okay, students, we have the two relations here. It is the work done by the gravitational force and it is the work done by the normal reaction. Let's do one more. Then we are going to do the work done by the applied force. The work done by the applied force. Okay, so students, this is the third case, and this one we are going to do the work done by the applied force. Here, you know that Work is equal to Fs cos theta, students. Okay, students, work done can be had with the relation W is equal to Fs cos theta. So this here, the work done is equal to force, we got it, and displacement, let it get displaced through a distance of S, Fs, and line of action, see, is the theta only, is the work done by the gravitational force. Okay, students, then next one we will do, what is the work done by the frictional force. Okay, students, we are going to do the work done by the frictional force. Now observe the diagram, students. Here, this is the body which is lying over the surface, and it is the weight of the body acting vertically downwards. Okay, students, we learned that it is the rough surface which has the coefficient of friction of mu, and obviously it is the normal reaction. Okay, students, then we have to do the work done by the frictional force. It is the applied force, we call it as the F cos theta, and obviously the frictional force will work in this direction. Okay, students, here as you know that frictional force is directly proportional to normal reaction. Okay, students, and it could be written as F is proportional to what, we have to write the value of the normal reaction. If you watch it carefully, actually the force is acting on the body in this way, and force is resolved into the components. Okay, it is F sine theta. Okay, students, then we can write normal reaction. We had to know the value of the n, that's why I am writing here. See, in the diagram, n plus F sine theta is equal to mg, and obviously n is equal to mg minus F sine theta. Okay, students, since normal reaction has a value of this, we can write F is proportional to n, or we can write F is equal to mu n, where mu is the coefficient of friction, and put the value of the n here, mu of mg minus F sine theta. Okay, students, then we need to find the work done by the normal reaction. Listen my word, sorry, work done by the frictional force, that is W is equal to Fr cos theta. Here force is the frictional one, that is mu of mg minus F sine theta. Okay, students, into R cos theta. It is the amount of work done by the frictional force. Okay, students, let's do one more problem. It is one of the applications of the constant force. The problem is given like this, students. A body displaced from, he gave a position vector, that is 2i cap minus 4j cap minus 6k cap meter, to 6i cap minus 4j cap plus 2k cap meter. Under a constant force, he gave, it is 2i cap plus 3j cap plus 6k cap Newton. He is asking us what is the magnitude of the work done. We have to find out the magnitude of the work done, students. Here this problem is given in the vector form, and you know that the dot product of the two vectors gives the work done. Okay, work done is the dot product of force vector and as well as the displacement vector. Okay, students, in this one, here we can write the relation as W is equal to f cos theta into dr. Okay students, we have to find out the derivative of r, that means what, the difference between the two. Then you can write it as dr is equal to rb bar minus ra bar. It is the change in position of the vector. Okay, and it could be written as 2i cap minus, sorry, it is 6i cap minus 4j cap plus 2k cap minus 2i cap minus 4j cap minus 6k cap. We have to take the difference of these two. Then what we get? 6 minus 2, 4i cap minus 4j cap plus 4j cap. It is 0 and c plus 8k cap. Okay students, we have the vector, it is 4i cap minus 0j cap plus 8k cap meter, and we had the force vector f bar is equal to 6i cap minus 4j cap plus 2k cap Newton. Okay students, and you know that work done is equal to f cos theta into dr, or we can write work done is equal to f bar dot s bar, that is f bar dot dr bar. Okay students, and you know that the dot product of the two vectors a bar dot b bar can be written as ax bx plus ay by plus az bz. Okay students, we are doing the same. We are using this relation here in this one. If you say it is a and that automatically is the b, same way we are doing, that is w is equal to f bar dot s bar, I mean dr bar. Okay, ax bx, 4 into 6, 24. Okay students, and 0 a by b by plus az bz, 8 into 2, 16. Okay students, it is 24 plus 16, it is 40 joule. I hope you understood this problem. To understand this problem, you have to remember the dot product of the vectors, then only it might be easier for you. Or simply remember this relation. If two vectors, okay, the vectors are a bar is equal to axi cap plus ay j cap plus az k cap, and b bar is equal to bx I cap plus by j cap plus bz k cap. If they have been multiplied, then we get here the I and I are parallel. That's why the dot product of the I and I is equal to 1, since the angle is equal to 0. That's why I took j to j. The angle is 0 and here it is 0. Cos 0 is equal to 1. That's why we got this relation. I hope you followed this problem. Let's see this problem students. What is saying? A block of mass 2 kg is suspended in a lift by a string. The lift starts moving down with an acceleration of 1.8 meter per second squared. Find the work done by the tension during the first 5 seconds. Is a problem students. Here first we have to draw the free body diagram students, then the things will be easier for you. Let's say it is the lift, okay, being suspended by a string, and this we suspended a pendulum bob, and he said that the lift is moving down with an acceleration of a. Okay students, Then we have to find out the tension. You know that weight is acting vertically downwards, and it is the tension. It always moves away from the point of contact. Okay, students? When the lift is coming down, you know that the tension is equal to m of g minus a. Okay, and you know that if it is moving up, it could be rewritten as m of g plus a is the tension. Okay, students, he is asking us the amount of work done by the tension during the first 5 seconds. We know that work done is equal to Fs cos theta. Here, instead of the force is tension, we are writing work is equal to Ts cos theta. Okay, students, where yes, this is the displacement. Let's assume the lift started from rest. Obviously it starts, and its initial velocity is 0. He gave the time as 5 seconds. We have to find out the work done after 5 seconds. Then I am using the equation S is equal to ut plus half at square to find out the displacement. As is equal to 0, 0 into 5 plus half. Okay, students, and acceleration is given into 1.8 into 5 square. 2 1s are 2.9s. S is equal to 0 plus 25 into 0.9, students, and we get the acceleration. It is displacement meter. Okay, students, then after we have to find out the magnitude of the tension. T is equal to m of g minus a. The mass of the block is given. It is 2 kg. It is 2. We are taking g as 9.8 here, minus 1.8. That is 2 into 8, students. It is 16 Newton. Okay, students, we had the T value and as well as the S. And what about the theta? Okay, lift is coming down. See, the tension and weight. Here, theta is equal to 180. Okay, and substituting the values we get, work done is equal to T S into cos 180. Obviously, cos 180 is equal to minus 1. Then you can write W is equal to minus Ts. Here we are substituting the value of the T. It is 16 multiplied with the displacement we have. It is 225 by 100. Okay, 4 25 4s 25 9s 9 6s 54 9 1s 9 14. Work done is equal to 144 joule after 5 seconds of the journey. I hope you understood this problem, students. Let's solve one more problem, students. In this problem, two masses are given, students. It is a 2 kg and is the 1 kg. Being suspended by a string. It is the string, students, which is moving over a frictionless pulley. Okay. Then he is asking us in this problem, if the masses are released from the rest. They are released from rest means what? Initial velocity of the system is 0. Find the work done by the string after 1 second. We have to find out the work done after 1 second. Say this heavier mass as a lighter. Let's say it is M1 and it is M2 students. Okay, students. Here the weight of this one works vertically downwards. You say it is M1G, and its weight, say it is M2G. Okay, students, and immediately the tension will develop. Here it is the point of contact, is the direction of the tension, and here also is the direction of the tension, students. Okay, first we have to find out the acceleration of the system, then after we have to find the tension in the string, students. If you go conventionally, we will get the acceleration easily, students. Acceleration can be had as net force by total mass. You know this. Okay, students. Net force, say this, is the weight is said, it is M1G. The weight is, what's that, 2 into 10. It is equal to 20 Newton. And here it is 1 into 10. 10 is acceleration due to gravity, 10 Newton. That means the net force is the difference between the two forces, that is M2G minus M1G by total mass is M1 plus M2. If you put the values there, you will get it is 20 minus 10 by 3. We had the acceleration. We got the acceleration of the system is equal to 10 by 3 meter per second square, students. We got the acceleration now. We need to find the displacement of the pulleys. What amount it get displaced up, the same would be found in the string. That means it is a single system. Okay, students, what this pulley got the displacement in upward direction, the same it will yield. That means what? It is a single system. Then we are using the equation S is equal to ut plus half at square. Okay, students, it started from rest means what? S is equal to half a into t square. T is given as 1 second, and you can find out the displacement. S is equal to half into a, we had 10 by 3 into 1 squared. It is 10 by 6 or 5 by 3 meter. We got the acceleration and displacement. Okay, we have to do the work done, students. Work done by the string on the first mass and as well as the second mass we have to find. Okay, students. Here work done can be had by the relation W is equal to Fs cos theta, isn't it, students? Here F is nothing but the tension and displacement is obviously displacement, and we have to choose the angles cos theta. Let's find the tension in the string. Okay, we are using one of the equations. See this? I am taking the free body diagram of this. Okay, from this, weight is more than the tension. Okay, students. Then we can write the relation as M1G minus T is equal to net force. It provides the acceleration. Okay, students. We have the mass. Mass is equal to 2 into 10, 20 minus T is equal to 2 into, already we got the acceleration. What we have, it is 10 by 3. Okay, students, it is 20 minus T is equal to 20 by 3. Then T is equal to 20 minus 20 by 3. It is equal to how much? 40 by 3 Newton. We got the tension also, students. Okay, let's take this one. The tension is working vertically upwards and displacement is also in upward direction. See this. See this diagram, students. Then obviously the angle between the tension in the string and as well as the displacement is equal to 0, since they are parallel to each other. Okay, for first block, or second for second block we are doing. T and S are parallel, then theta is equal to 0, students. Okay, students, we have to use this relation. Work done is equal to T. What we got, it is 40 by 3 into displacement we have, somewhere we got displacement, it is 5 by 3 into cos 0. Okay, students, it is 200 by 9 joule, students. In the same way, say this, here in this one, the displacement and as well as the tension are in opposite direction, and theta is equal to 180 degree. Okay, for first block, okay, we are using the same. W is equal to Ts cos 180. Since cos 180 is equal to minus 1, work done is equal to minus Ts. We yield the same result, that is minus of 40 by 3 into 5 by 3. It is 200 by 9 joule. I hope you understood this problem, students.